Hello everyone, welcome to this lecture in the Decision Trees from Scratch series. Today we will finish building the classification decision tree, an endeavor or a process which we started 2 to 3 lectures back. If you are watching this as the first lecture of this series, no problem. I have designed the lecture so that it's self contained, but I highly encourage you to watch the previous lectures if you are not familiar with concepts such as Gini impurity, etc., because that's a concept which I'm assuming you know in this lecture. So let's get started. First, let me introduce the problem to you, to all those who are tuning in for the first time, and just as a recap for everyone who is following. This is the training data which we have. We have essentially collected data for 7 people, and we have asked them questions such as, do you love movies? That's the first question we asked them. Then, do you love cartoons? The third question is, what's your age? And essentially the fourth question is, do you love Batman or not? So we have collected all these data from these people. You will see that the loves movies, loves cartoons, and loves Batman. These answers are either yes or no. But the age, if you see, is an integer numerical value. The goal is that we have to use this training data to predict if any new person loves Batman or not. So let's say you have this training data, and if you meet a new person, you ask them, hey, do you like watching movies? Do you like watching cartoons? And what's your age? Based on these three answers, you should be able to predict whether the person likes Batman or whether they do not like Batman. That is the main problem which we are trying to solve. And the way we are solving this problem is by building a classification tree completely from scratch. So we started this 2 lectures back where first we spent a lot of time understanding terminology. Then we understood a concept called as Gini impurity, which essentially quantifies the impurity score for a leaf. The lower the Gini impurity, the better it is. And using this quantitative metric, we can determine which question should come first in the decision tree. So, at the end of the previous lecture, we have already decided what should come at the root node. The root node is essentially the first statement or the first question which needs to be asked in the decision tree. And there were three options for us. The first option was loves movies. Um, the first option was loves movies. The second option was loves cartoons, and the third option was age. Because if you see, all of these are the three questions which have been asked. Now we designed a mathematical procedure to help us understand which of these questions should be asked at the top of the decision tree. And for that, we calculated the Gini impurity for all these three. And for the loves cartoons, the Gini impurity turned out to be the lowest, and its value was 0.214. I've demonstrated it over here. So for all of these, what we did is we designed a decision tree map like this. So if the question is loves cartoons, we can go in yes and no. If you go in the yes compartment, you will see that. So let's say loves cartoons and yes. So there are 1, 2, 3, and 4 people. And if you see their responses, you will see that one person says no and 3 people say yes. So it's been written as one no and 3 yes. Similarly, if you go in the no compartment here, you will see that 3 people do not love Batman and 0 people uh, love Batman. Essentially, all people who don't love cartoons are not loving Batman. So this is a decision tree map, and based on these values, we compute a score called as Gini impurity. So if there are mixed classes, so for example, in this leaf here, there is answer yes as well as no, which means it is impure leaf. Here, if you look at this leaf, the answer is only no. There is no yes. So it's not a mixture of classes, which means it's a pure leaf. Having a pure leaf is good, and it really reduces Gini impurity. So I think for Love's movies, the Gini impurity was somewhere around zero point 0.4, and for love, the age, uh, so let's see actually these values. Yeah, for Love's movies, the Gini impurity was 0.405, and for age, the Gini impurity was 0.343. So it was really the lowest for the loves cartoons question, and that's why we use it as the root node. Great. In today's lecture, what we are going to look at is that after deciding the root node, how do you finalize the nodes after that? which are also called as the internal nodes or branches. And then finally, how do you finalize the leaf node? In short, we will complete building the decision tree process in today's lecture. So it's a very exciting lecture. Let's get started. First, let's recap where we are. We have decided the first question which we are going to ask, that's loves cartoons, and that segregates people into two types. Four people go in the yes compartment over here, and three people go in the no compartment, which can be seen from this diagram. There are in the yes compartment there are 3 plus 1 equal to 4 people, and in the no compartment there is 0 plus 3 equal to 3 people, right? And in the decision tree map, as I showed you before, it looks like this. Now, if you look at the left leaf over here, so I'm calling this as a left leaf. This is an impure leaf, right? So some further analysis needs to be done on that because it still has a mixture of classes. But if you look on the right leaf, if the person says they don't love cartoons, we can, for all the people, we can say that they don't love Batman. And there are three people here. So this leaf is actually fully pure, which means that it does not have a mixture of classes. And so we don't need to split the decision tree any further on this branch, because it's already pure. We already know that all the people who are coming in the no, they don't love cartoons, they would not like Batman since they are in the no category here. So we don't need to split the decision tree further after this point. But if you look at the left leaf, in the left leaf, if you see, three people say yes that they do love Batman, and one person says no. So it's a mixture of classes and it's an impure leaf. So that's why we need to split this leaf further and we need to decide what question to ask. Now, the next question to ask comes from what we have in the training data. So loves cartoons is actually fixed. So that question has already been asked. So I cannot ask this up. First, let me actually erase some things here. Yeah, okay. So loves cartoons question has been already asked. So I can either ask the loves movies question or the age. So when I look at this left leaf category here, there are four people here in this category. We can ask these four people or we can split these four people based on either the loves movie question or the age question. So the first question which I asked is loves cartoons, and that give me yes, no. In the no category, we have already stopped splitting the decision tree because that leaf is pure. In the yes category, we can either ask the whether they loves movies or we can look at their age. So we have to decide what should come at this particular node over here. So this is an internal. It's also called. It's also called as an internal node or a branch. We need to decide what question to be asked here. And like always, how to decide this? We will use the mathematical measure which is called as Gini impurity. As I told at the start of this lecture, if you are not aware of this terminology, there is a separate lecture in this series which is entirely devoted to understanding Gini impurity. So I would highly encourage you all to go through that. So what we'll be doing is that we'll be looking at these four people and we'll be computing the Gini impurity for the loves movies question and for the age. So let's see how to do that. First, let's look at the training data again and let's look at the four people who answer yes to the question of love cartoons. So let's look at these people. This is the first person over here. I'm marking as one because they have answered yes. Then this person has answered yes, this and this. So these are the four people. So I'm marking them as 2, 3, and 4. So these are the four people which we are going to be looking at. So we will construct decision tree maps for both loves movies as well as age, and based on the decision tree maps for these four people, we will be computing the Gini impurity. So let's start with the decision tree map for the loves movie question. So it will be yes and no. First, let's go to the yes category. So let's look at these four people and let's see out of these four how many have answered yes to loves movies. So it seems there is one and one. So there are two people who have answered yes. So let's look at whether they love Batman. The first person does not love and the second person loves Batman. So it is one yes and one no. So in the yes loves movies category, we have one person who loves Batman and one person who does not love Batman. Great. Now let me go to the loves movies no category. So which means there are two people here, this person and this person, and let's see whether they love Batman. And we can see that indeed both of them love Batman here. So there will be two yes and there will be zero no. Okay, so this is the left leaf here and this is the right leaf here. To compute the total Gini impurity for the loves movies question, we'll compute the Gini impurity of the left leaf and the right leaf and then do a weighted sum. So the Gini impurity of the left leaf is 1 minus the probability of yes whole square minus the probability of no whole square. The probability of yes is just 1 divided by the total number, which is 1 by 2, and the probability of no is also 1 divided by the total number of people here, which is 2, so 1 by 2. So the Gini impurity of the left leaf will be 1 minus 1 by 2 whole square minus 1 by 2 whole square, that will be 0.5. On the right hand side, the Gini impurity will be 1 minus probability of yes square minus probability of no whole square. The probability of yes is 2 divided by the number of people is 2. So 2 by 2 whole square minus 0 square. So the Gini impurity will be 0 on the right leaf. And you should have already predicted this because it does not have a mixture of classes. It's a pure leaf. So the Gini impurity for the left leaf is 0.5 and the Gini impurity for the right leaf is 0, right? And then we need to find the weighted Gini impurity. So there are two people on the left side and there are two people on the right. So the total number is 4. So the Gini impurity score on the left side will be multiplied with 2 by 4 and the Gini impurity score on the right side will be multiplied by 2 by 4. So the final Gini impurity of the loves movies question will be 2 by 4 into zero point 0.5 plus 2 by 4 into 0. That will be 0.25. So this is the Gini impurity for the loves movies question. Now let us look at age. We can calculate the Gini impurity for multiple different age points such as 7.5, 12.5, 18.5, etc. And I encourage you to do that. But right now I'm just going to show the Gini impurity calculation for age less than 12.5. So you can even do this for age less than 15 and the calculation will stay the same. So if you ask the question age less than 12.5, right? And let's look at the yes and the no category. First, let's look at the yes. So let me go here again. Age less than 12.5, it means there is only this first person. And let's see if they love Batman or not. So first, let me rub some of these things here. Okay, so if age less than 12.5, which means it's only one person here, and we can clearly see they don't love Batman. So no will be 1, and yes will be 0. So no will be 1, and yes will be 0. Now let's look at the no category here, which means age greater than 12.5. So among these four people, it's this person, and this person whose age is greater than 12.5. And let's see whether they love Batman. So we can actually see that all of them have said yes, that they do love Batman. So the answer in this leaf is that 3 have said yes and then 0 have said no. Now without even calculating the Gini impurity, I can predict because in the left leaf there is not a mixture of classes. It's just one answer. So the Gini impurity of the left leaf will be 0. Similarly, on the right leaf, uh, there is not a mixture of classes. All of them have answered yes. So the Gini impurity of the right leaf is also 0. And so the total Gini impurity of the considering the left leaf and the right leaf is going to be 0. Uh, so for the age less than 12.5, the Gini impurity is 0. Now, one thing to test is that I highly encourage you to test this for age less than. So try to find the midpoints here among different age brackets and test the Gini impurity for age less than 15, age less than 25, age less than 36, age less than 43, etc. Try to find the Gini impurity for all of these. You will see that only for age less than 12.5, the Gini impurity is 0. And remember, we want to minimize the Gini impurity as much as possible. So when we started splitting for this Loves Cartoons yes branch, when we started splitting it further, our goal was to look at two questions, Loves movies and age, and then choose the one with the lowest Gini impurity. Now that has become pretty clear for us, right? Because the Gini impurity for age less than 12.5 is 0 and the Gini impurity for Loves movies is 0.25. So we should definitely choose age less than 12.5 as the next node, as the next internal node or the branch. So Gini impurity for age less than 12.5 is equal to 0. Hence, this question should be asked at the next stage of the decision tree. So we have asked the loves cartoons question. In the no branch, it will just stop as we saw, but in the yes branch, now we should ask the age less than 12.5 question. We have figured this out. That's great. Because the Gini impurity of this question is 0 and it cannot get lower than that. So at this stage, we are at a state where we have finalized the root node, loves cartoons, in the yes and no. In the no category, we have reached this leaf, which is already 100% pure. In the yes category, we have asked this question age less than 12.5. And yes and no. If you bucket this into yes and no, we'll get these two leaves. So the left leaf here is this one, and the right leaf here is this one. So there are three leaves here actually. There is the first leaf, there is the second leaf, and the third leaf. Now I want you to look at all these three leaves and look at their purity. So let's look at the first leaf. It has all the no categories, no yes category. So it's completely pure. It's not a mixture of classes. Let's look at the second leaf. It has all the yes categories and it has no in the no category. So it's fully pure. It does not have a mixture of classes. Similarly, in the third leaf, if you see all the answers are no and there is zero people who have answered yes. So here again it's not a mixture of classes and this is fully pure. So all these three leaves are actually 100% pure, and this is an indication that we have constructed a decision tree and we should stop here. So if the leaves are not pure, that's when we have to do further branching. But now we have reached a stage where all the leaves are pure. So we should stop here. In fact, 1, 2, and 3 are the last nodes of the decision tree and they are also called as leaf nodes. So let me write this here 1, 2, and 3 leaves. They are the leaf nodes because they are 100% pure. So we will stop splitting the decision tree at this point. Great. But there is still one more thing left. We have to assign an output value, whether they love Batman or not. And that's actually pretty simple. To assign the output value, just look at the class which has the higher value. So, for example, in this branch, the output value will be they don't love Batman. In this branch, the output value will be that they do love Batman because three people have answered yes and no at zero. And in this branch, the answer will be that no, they don't love Batman. So the next step is to select the output value for each leaf by picking categories with the highest counts, as I demonstrated to you. So the final decision tree which you have constructed looks like this. You ask the question loves cartoons, it will be yes and no. If it's no, that person does not love Batman. If it's yes, you look at their age. If the age is less than 12.5, it means they do not love Batman. If the age is greater than 12.5, they indeed love Batman. Amazing. So we have actually constructed the entire decision tree from scratch. And if you have been following this series, this is the exact decision tree which we started with. So in one of the previous lectures, I showed you an optimal tree and I showed you that we want to reach this point. And now as this lecture comes to an end, we have reached this point uh, where we have constructed this tree. So this classification tree has been completely built from scratch. We did not assume anything. Just by using one mathematical metric, the Gini impurity, we decided which question to be asked at different nodes. And that proved to be a very powerful tool for us, Gini impurity. There is another tool which people sometimes use and that's called entropy. I covered it in the same lecture as Gini entropy. So you can go through that lecture to see the similarities and differences between Gini entropy, Gini impurity and entropy. Now we have reached the conclusion where we have built the entire decision tree from scratch, right? So there are some problems though, which I will also dive deeper as the series proceeds into Python coding. But some problems which you should notice is that look at leaf number one. In leaf number one, there is actually only one person, right? If you look at leaf number one, there is only one person who has answered no. This is not good generally because it's hard to have a confidence that the tree will do a good job in making predictions with new data. So if a new person comes and if I go into this branch, I will be very less confident because I've trained it with only one person in this leaf. That is not good at all. Usually there should be more people in leaves. So that is one problem, that ideally there should be at least two to three. That number varies, but it should definitely be more than one. So although the leaf is 100% pure, but there are very few people here. So although we have achieved 100% accuracy on the training data, the problem is that whether it does well on a new person or not is questionable, because there are very few people in this leaf. And there are two ways to solve this problem. The first way is called as pruning, and we'll look at this in detail when we look at the Python coding part. The second way is to put limits on how the trees grow. So, for example, we can put a limit that there can be a maximum, there have to be three or more people per leaf. We can put this limit. Now, the problem is that if we put this limit, then this leaf won't be there. That's probably fine if our focus is on a better forecasting. So we can put limits on how tree grows. So we will reject those leaves in which there are less than three people. So if we had put this limit on this particular problem, we would have gotten this tree. It would not have split further, because then some leaves might have less than three people. Now let's say if we had this decision tree as the final tree. Do you see the trade-off here? The trade-off is that although in each leaf there are more number of people, that is good, right? That solves the problem which we are facing here. But there is less accuracy. So, for example, if you look at the final leaf, it's a bit impure, right? So, there is a 75% accuracy here, since one person will be classified wrongly. Now, the answer would be, so this decision tree will be looking like this. If the person loves cartoons, no, they don't love Batman, don't love Batman, and yes, they love Batman. Now that is our decision tree finally. Let's actually test this on the data set. So we are saying if they love cartoons, they love Batman, and if they don't love cartoons, they do not love Batman. So already if you look at the first person, they love cartoons, right? But their true value is they don't love Batman, and our tree will make a mistake here. Our tree will be correct on no, because all the people who don't love cartoons, they don't love Batman in the data set also. And all the people who love cartoons, they generally love Batman except for this first person. So this decision tree which I have showed right here, this decision tree will make mistakes on the training data. And that is probably fine, because remember, in machine learning the goal is to do good performance on data which the tree has not seen before. So even if some mistakes are made on the training data, if the prediction performance is better, we should probably go ahead with this tree, right? This is very similar to overfitting when we looked at regression and classification. We do not want the decision tree to overfit. So for example, this decision tree, it has gotten 100% accuracy on the training data. It will not make a single mistake, but it is probably overfitting, because since there is only one person here, it will not do a good job on new data. This tree, on the other hand, makes some mistakes on the training data. It achieves 75% accuracy here because this leaf is impure, and that's why it makes mistakes on the training data. But that's probably fine, as I mentioned, because since there are more people in each category, we have more confidence that on new data, this tree will do a better job. So, this is the first link between decision trees and machine learning. This is the concept of overfitting, right? Very similar to regression and classification. The second link is how do you choose the limits which you put. So here I have told you the limit which you are putting is that I will not accept a leaf which has less than three people, so it has to be greater than or equal to three. Where does this number 3 come from? It turns out that it's actually chosen through cross validation. We choose a number of different we choose a number of different thresholds, like 2 people, 3 people, 4 people, and we see which number does a good performance on the test data. So similar to ML algorithms, even in decision trees, we divide the data set into training and testing. And there are similar things such as cross validation, then overfitting, like what we saw here. There is one more terminology called pruning, which we'll look at later. You see, slowly we are starting to see the similarities between decision trees and why they come in machine learning. It will be much more clearer to you when we move ahead with the Python coding part. For now, let me just summarize what we have done. So I'll make this summary in 5 steps. Initially, when we started with this problem, we had a data set which looked like this. We had 7 people. We collected their data for loves movies, loves cartoons, age, and loves Batman. And the goal was, if a new person is given, based on whether they loves movies, loves cartoons, or what's their age, can we predict whether they love Batman or not? This was actually the problem which we started with. In the summary, the first step what we did is, from the entire data set, we used Gini impurity to select the root node. So what we did is, for these 3 questions, loves movies, loves cartoons, and age less than 15, we wanted to select the root node, what should come at the start. So we computed the Gini impurity for all three. The Gini impurity for loves movies was 0.405, for loves cartoons it was 0.214, and for age less than 15 it was 343, 0.343. So for loves cartoons we had the lowest Gini impurity, and hence we selected that as the root node. That was the first step which we did. The second step was, once we selected loves cartoon as the root node, 4 people went to the left and 3 people went to the right. So 4 people went to the yes they do love cartoons, and 3 people went to no they do not love cartoons. Now in the no branch we got a pure leaf already, so we stopped splitting the decision tree on the no branch. But then we looked at the yes branch further, because this is an impure leaf. So we use the 4 people who loved cartoons. So we use the 4 people who loved cartoons, and we use Gini impurity to find the next node, whether it should be loves movies or whether it should be age. So that's what we saw in today's lecture. We found the Gini impurity for loves movies to be 0.25 and Gini impurity for age less than 12.5 to be 0. As a result, we selected age less than 12.5 as the next node. And up till this step number 4, we are at this stage where we asked loves cartoons, yes and no. In the yes trajectory, or in the yes branch, we asked age less than 12.5, and then again it split into yes and no. This kind of a structure gave us 3 leaves: leaf number 1, leaf number 2, and leaf number 3. We saw that all of these leaves are 100% pure. So we stopped splitting the decision tree. And then the last step is, we selected the output value for each leaf by picking the category with the highest counts. So here in the leaf 1, no category has the highest count. So we picked no, they don't love Batman. In the second leaf, the yes category has the highest count. So we picked yes, they do love Batman. In the third leaf, uh, the no has the highest count, 3. So we picked that they do not love Batman. If we go ahead with this approach where we put limits on how tree grows, here we can again look at which category has the highest number, and that will be the answer. So here in the left leaf, the 3 was yes and 1 was no, so the answer was loves Batman. In the right leaf, 3 were no and 0 were yes, so the answer was don't love Batman. So this is the last step, and after selecting the output value, our final tree looked like this: loves cartoons, yes, no. Then ask for age less than 12.5, split it into yes and no, and finally we get, for yes, if age is less than 12.5, they don't love Batman. If age is greater than 12.5, they do love Batman. And if they don't love cartoons in the first place, we can confidently say that they don't love Batman. So we have finally finished building a decision tree completely from scratch, and I deliberately had a whiteboard approach until this lecture, because I have seen that many people directly start coding decision trees in Python and they don't understand the basics of how it is implemented. This whiteboard approach will give you an intuition, it will develop your understanding, theory, clarity about Gini impurity, entropy, etc. Today I have also showed you 2 things. I have shown you the need for pruning. I did not explain what pruning is. And I also showed you the need for cross validation and the concept of overfitting, which also shows up in decision trees. So now I think if you have reached until this point, you are ready for the Python lecture. So in the next coming lectures, we will be looking at the Python implementation of classification trees. If you have understood up till this point, I think you will really understand those lectures. I plan to cover those Python lectures in a lot of detail in a very, very hands-on approach. Uh, so these lectures on the whiteboard will really serve as a strong foundation for understanding those lectures. So thank you so much everyone, and I look forward to seeing you in the next lectures.